So in your head, what's an inference? An educated guess. So if I were to ask you guys, what is a statistical inference? What do we educate ourselves with in statistics, and what do we make guesses about? So what we do is we gather data from. When we go and gather data, do we gather data from everyone? Yeah. So in some respects, statistical inference is using a sample to make a conclusion about a population. Okay? And so when we talk about an educated guess, we use the sample to educate ourselves, and then we use that, what we've learned from the sample, to make a guess about the population. Okay? All right. And so Unit 6 is going to have all the theoretical statistics behind it on top of how to do it for proportions. Okay? So if the p-hats are approximately normal, then it's easier to make conclusions. Think about those first examples that we did yesterday where I was like, oh, where are the middle 96% of these values? Or what's the probability we could have gotten that sample of 67% or less? Both of those, when you think through what those mean, those would have been much more challenging questions to answer if we didn't have a normal distribution of those p-hats. Okay? So we're basically going to learn about two different kinds of statistical inference. Okay? And then we're going to learn within one kind of statistical inference. One of those is making an estimate, and the other one is testing a claim. We're going to talk about both of those. And then we're going to have different sets of rules for when we make an estimate about p, or an estimate about mu, and so on and so forth. So we're going to learn lots of different ways to make statistical estimates, but all of them are going to follow the same basic structure. Okay? And to kind of talk through this structure, I wanted to take you through a similar idea that's not necessarily a statistical idea. Okay? So what I need you guys all to do, next to the word point estimate, I'd like you to pick a single number to estimate the age of Mr. Wyan. Single number. How old is Mr. Wyan? Everybody good? I'm going to guess his age to be 38. How many of you feel good about your estimate? I'm just going to come and take a look, Steve. I happen to know his actual age. Wow.
And then they start looking different again.
So when I picked Mr. Wyan, did I do a good job of picking someone that is like, oh, I don't know?
Mm-hmm.
Do you know who else is really good for this activity? Mr. Johnson.
Oh yeah.
I have no...
We're in the common space. Do you hear
No, but we'll be happy to yell at you.
that? Okay.
Is it mostly freshmen? Because we could give him like the scary, intimidating upperclassmen.
I wouldn't do that. No.
Neither would I.
No offense. You're not intimidated.
You say that. But you see this little scary figurine? This was given to me because a student thought I was scary.
No. It was a joke, wasn't it? She's not
I think
scary.
Nurse Monster's intimidating.
Oh, really?
I hear from students relatively frequently that I am intimidating.
Because she's very sarcastic, I feel.
Very sarcastic.
And you don't know it, you think she's...
Listen, if you're going to be saying mean things about me.
Nice.
Mrs. Nutter, I can tell you unequivocally they are very bad at estimating these guys.
Estimating.
Not a single one of them got the right answer to how old Mr. Wyan is. Not a single one of them.
Well, it's because he looks like... Wait. Let me guess. Did you all guess?
They don't know the answer yet.
Do you know the answer?
I do. It was not my guess. By the way, I always, whenever I do this, I make the guess in advance.
You scared me.
I make you guys. I happen to text him, and in fact, I know. I don't know if you've read your email in the past half hour.
No.
I know to the nearest quarter year how old he is, because today happens to be his half birthday. Matt.
You know his age?
No.
If you had to guess, how old would
Guess.
you guess him to be?
I don't like this math part.
But you're guessing. You know how old Matt is? Oh, yeah.
Do you know his exact age?
Well, I'm within a year. I know what.
Oh, what a great idea. You guys, how many, given that I told you guys you were all wrong, because you are. Even if I didn't say to the nearest half year.
34.
I was saying 32.
He's absolutely 39 or 40.
No.
Oh wait, it's his half birthday. He's 39
And a half.
and a half.
Dude, are you
Oh,
serious?
was I not supposed to say that?
You weren't supposed to.
Oh, sorry. Sorry. Okay, but I just want to let you know. I was like, oh, Mr. Richards is so loud. His garage door's open. No, it's not.
It's me.
Sound does travel.
Okay.
No, so when we get, you guys, when they just sent us the email about hanging stuff, right? We need to get like sound absorbing.
How is she reading the emails like all day long?
No, this one they emailed yesterday. We need something sound absorbing for this wall, because they're bouncing right out here and down the hallway.
Alright, see ya. Wow. Great.
You guys, that was like the calmest department meeting between the math department has ever been.
Y'all need a sitcom or something.
A sitcom?
Y'all need to share one apartment.
Okay, which?
And like,
There's only one of those people I'd be willing to share an apartment with.
Who's down there?
For sure.
Yeah. She would be like, she would make you tea, I feel. She would just be so great.
you've been thinking about it?
I was just thinking who would be the best. Miss Lombardi would be a lot.
Yeah, she's a lot. I mean, I love her to death, but she's a lot.
Yeah.
So is he.
Mr. Richards would he would wake you up in the morning, like with your alarm would be him. Yeah.
I would be everybody's alarm in the morning. I'd be making my coffee, and I'm not quiet about it because I feel like if I have to be awake, everybody should be awake.
I agree. I have to wake my entire family up.
So anyway, Miss Lombardi did say something. Mrs. Turner did say something kind of interesting, right? She said I could guess within a year. Everybody with me? So, and in fact, I'm going to do this in every class, and you're not going to give away his age to anybody else, okay? Because Miss Lombardi, I wasn't going to tell you guys until Thursday, because Miss Lombardi, but she just ruined it for everybody, okay? All right. Nobody's going to guess 39.5 anyway, right? Like, if someone's going to guess a year. So, and if we wanted to get even more particular and precise, we could, right? Oh, he's 39.5 in 4 hours or something, right? Or he might be 39.48 hours, right? Because he depends on what time of the day he was born or whatever, and even what time zone he was born in, and time is relative. But in the basic premise of your birthday tells you how old you are, 38. Or for some of you guys put 34 or 37, so on and so forth, right? Okay. And if I were to say, how confident are you that you were right, your answer is probably not very good. Even when we say, well, do we know he's 38? Because it could be 38.2, right? And so when we say, how confident are you? Most people would be like, I'm not very confident at all, right? Right? So instead, what we might do is we might say, hey, I think he's 38, but I'm going to give myself plus or minus 2 years. And for Miss Meister, that creates an interval, right? It'd be something like 30. I'm saying, oh, he's somewhere between 36 and 40. So what would your interval be? Write down what if you gave yourself a plus or minus 2 years, we would all end up with an interval, right? And since we all got a different guess, we'd get a different interval, right? Some of you guessed 37, and so you'd be at, 35 to 39, and some of you guessed 33, so you'd be at 31 to 35. Everybody with me? Okay? And so what if we were to think of ourselves as each one of our guesses was a sample, and then we have that margin of error? And so since all of us would get maybe a different sample, we'd all have a slightly different interval, but they'd be about the same. Are we all comfortable with this idea? Okay. And so a point estimate is a singular number, your guess. Okay? Then you have your margin of error, and then you end up with something called an interval estimate. Okay? And with an interval estimate, we hope that Mr. Wyand's true age is somewhere in that interval. Now that we know his true age is 39.5. How many of you guys have the right answer? Have an interval that contains his real age? Every single one of the rest of you, guess what? Your interval underestimated his age, yes? Mm-hmm. I think it's his hair also that makes him look a little bit on the younger side, for sure. So we can say there's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of us right now. 2 people, 2 of our samples out of the 12. So it's 1 in 6 is 17%. Everybody good? 17%? So right now, this margin of error, not a good margin of error, because we're only going to be right 17% of the time. In fact, we can only be confident in 17% of our answers containing the actual value. So what should we do? We already made our guess. We have our sample. Maybe what we should do to be right more frequently is increase our margin of error. Everybody good? So what if I instead had you come up with an interval estimate from your point estimate? We already have that point estimate, okay? This time for your margin error, you guys, use plus or minus 5 years. And again, so Miss Meister's would be 33 to 43.
So even though that we now have a higher frequency of people who are correct, does that make this less? I get it.
I get what you're saying.
Yeah.
You're stepping on the point I'm going to make in about 2 minutes. Okay. Now, raise your hand if you're this interval, this plus or minus 5 years with the larger margin of error. Raise the hand if your interval is correct and that it contains his real age. 5, 6, 7, 8. So now we're at 67% of us. So if we randomly picked one of our samples, we would be right 67% of the time, right? We're much more confident in our interval with that larger margin of error. Is everybody good? Okay, hold on. I'm still not okay with being right that percent of the time. So you guys, I want to do plus or minus 10 years. One more interval. So for Miss Meister, that would become 28 to 48. I bet we can be 100% confident now, yeah? I don't think anybody guessed less than 29. I don't think any of you did. I think you guys all picked in the 30s. Okay? We feel better now? All right, I got a slight problem with this. You guys, if I'm trying to estimate somebody's age, 28 to 48 is a 20-year window. You guys get what I'm saying there? How many of you guys have seen How to Train Your Dragon? Because it's like the best movie of all time. Every time I watch it, I think about Indy as a puppy, because that's when, because Indy's black and he was kind of a quirky, annoying puppy. And to this day, I regret naming him Indigo, because it doesn't really fit his personality. You know what I should have named him? Toothless. But Toothless turns out to, there's a word, that's like an actual word, right? Like not just a name of a dragon in a movie, right? What does it mean for something to be toothless? I mean, but like when I describe an argument as a toothless argument or something.
Has no, like, yeah.
This is a toothless interval. You guys with me? So as we develop this concept of margin of error, well, why is this toothless? Because my margin of error is so big that the interval is 20 years wide. And all of a sudden we have this like, what a stupid interval. Everybody good? Does that kind of make some sense as to why we... So, when you think about it, our margin of error, which I'm going to very frequently just call ME, yes? Okay, our margin of error is a balancing act. In that there's two things we care about. We want it wide enough that our interval is quote unquote right. It contains that actual value, that real thing we're trying to estimate. Okay? But not only do we want to be right, we don't want it to be, we still also need it to be narrow enough that it's meaningful. Does that kind of make sense? We don't want a toothless interval. All right. So when you think about these interval estimates, which is all statistics, what we do is we measure our point estimate first every single time. And then to our point estimate, which we actually, our point estimate is going to be something from our sample. So it's going to be a p-hat. It's going to be an x-bar. Okay, it's going to be one of those things. But you guys, what do we know about p-hat? And in fact, what do we know about samples in general? They're not perfect. So in fact, most of the time statistically, our point estimate is wrong. Cool? And in fact, did any of you have the correct point estimate? You with me? Okay? It's the margin that helps us get to that point estimate. Cool? So the structure of a confidence interval is that we take our point estimate and we add or subtract our margin of error. Okay, so at the beginning of this, we're going to do intervals for P. Okay, so our point estimate is going to be the value from our sample, which is going to be a p-hat, plus or minus the margin of error. And the reason we can do this, and this is a real throwback to the beginning of Unit 5, okay? We talked about what we call biased and unbiased estimators. If I take a whole, we each had those samples of his age, right? We each have a p-hat. Like if we all took a different sample out of this bin, we'd each get a different p-hat, right? What's the center of all those p-hats? P. The fact that the mean of the p-hats is equal to P that makes P hat an unbiased estimator of P. Now, you guys, let's go back to Mr. Wyan for a second. Was our process an unbiased process? No, his long hair totally biased you guys.
I can't even imagine him with short hair. He would look, I feel like he would look more older.
Did I tell you guys on the day we interviewed him? I can't remember who it was. It wasn't Grega. Somebody, like I was on the interview team for Mr. Wyan, and they came up and they was like, I thought you were interviewing for the new principal job, or the new assistant principal. I was like, we are. He's like, and they were like, oh, because that guy with the long hair, I thought he was interviewing for the band job. And it just made me giggle really hard. Because that long hair is not what you would expect out of a principal. Okay. So let's look at these structures a little bit more. Any of you guys prefer dark chocolate to milk chocolate? Me too. Well, it depends. If it's a candy bar, I want milk chocolate, but if it's pure chocolate, I want dark chocolate. Like if I'm just, like, so I don't eat like a Hershey's bar because that's weird. But like a Snickers, like a dark chocolate Snickers doesn't sound good. I don't know if that makes sense.
The dark chocolate Kit Kat though, it's really great.
And the dark chocolate Reese's.
Take your word for it. So I calculated the interval to be between 0.65 and 0.83. And so all we have to do, guys, is find some math to figure out what is the margin of error and what is the point estimate. And as we think that through, y'all, there's basically two different ways you could go about answering these two questions. I don't care which one, because they're both essentially the same thing. Cool? Any ideas?
It's a point estimate, a statistical.
You just find the distance between them and then divide it by 2.
So one way we could do this is like, you guys, when my margin of error was 10 years, how wide was my interval? 20, right? So the width of my interval is twice the margin of error. Everybody good? So if I wanted to find the margin, what I could do is say, well, how far apart are 0.83 and 0.65? And you get a 0.18? So what would that make my margin of error?
0.09.
And then I could divide that by 2, and I'd find that my margin of error is 0.09.
So
And if my margin of error is 0.09, how could I find the point estimate?
0.83 minus 0.09.
I could do 0.65 plus 0.09, yeah? And either way, we're going to get a number, 0.74. That's one approach. Cool. Another approach I could say is, well, what do I know about my point estimate? It's halfway in between these two numbers. Yeah? If I wanted to find the halfway point between two numbers, I could just add them together and divide by 2. You guys with me? And when I do that, I end up with 0.74. And then I could say, all right, so how far is 0.74 from each of these two numbers? So I could like subtract or whatever to figure, and then I would end up with 0.09. I really couldn't care less which way, whatever way makes the most sense to you. Another way we can kind of look at this is if we think of my interval as 0.65 and this is 0.83. my p hat is exactly in the middle. So sometimes like I can tell that this distance is that 0.18 and this distance is my margin of error. Like that's a physical representation of it to help you kind of think that through. However that makes the most sense to you. Are we all feeling good with this? All right. Let's go ahead and turn the page. Any of you guys go see the new Avatar movie? Was it good? Is it worth seeing it in 3D? Did you see it in 3D?
Yeah, it's worth
Okay. How long is it?
3 hours.
3 hours is a long time to sit at a movie theater.
Maybe it's just me, but I find 3 uncomfortable.
My stream was after 3 hours.
No, there was no intermission, but like I felt like it didn't feel like 3 hours.
For what?
For Endgame.
Endgame felt... Because Endgame has like 3 very different acts, right? Like there's definitely 3 acts, arguably 4 acts within Endgame. It's almost... Endgame could have been 2 movies.
I felt like Batman was like a movie and a half.
The most recent Batman?
Yeah.
Yeah, that one's pretty long.
But
And
it was like
it was good.
It wasn't miserably long. It was just like
Did any of you guys watch the Snyder cut of Justice League? The 4-hour version of it?
There's a 4 hour of what?
Okay, I gotta pause the... Wait, remember, the week after Tech Week is gonna be the worst week for you guys in here, for sure. Okay, you guys, 45% of people went to go see the new Avatar movie. We take a random sample of 1,015 people and ask them if they are willing to go see the new one. Okay? Everybody good? All right. Tell me something we know. Cool. So P is equal to 0.45. And you guys, the minute we know that N equals 1,015 and P equals 0.45, we actually can start thinking through a whole bunch of other things, right? So what would the sampling distribution look like? So let's go through the 3 things we might want to describe in terms of what does a distribution look like. The first one being shape. Without doing any calculations, are we comfortable in saying that NP and N1 minus P are going to be greater than or equal to 10? It's going to be about half of 1,015. They're going to be huge. They're going to be like 500-ish. Are we all comfortable with this? Okay. So the first thing we would check is that NP, N1 minus P being greater than or equal to 10. Without having to take the time to do those calculations. Never do this on the AP exam, by the way. You will do those calculations, but for brevity's sake, are we all comfortable with this? Okay. All right, so now I can say that those P hats are, in fact, approximately normal. And I'm just going to throw in some P hats here. And in fact, since there's 12 of us, I threw in a P hat for each one of us. I was trying to be adorable. Okay. All right. What else do we know? We've described the shape, right? So the next thing is the center. And what is the center of all the P hats? Which is 0.45. What is the standard deviation of those P hats?
Oh, it's square root.
0.55 all over 1,015. I'll let you guys help me out with that.
So there's the 0.55 is 1 minus.
This is my p. This is 1 minus p. This is the square root, or this is n, all under the square root. A reminder that, and again, that formula is on your formula sheet, so don't stress if you don't remember it. I just need some help with what that is. 1/6?
Yeah.
Exactly 1/6?
No.
So it's like 0.1.
0.016 rounded. I rounded up.
Got it. Okay, so got it. You didn't say 1/6. You said
0.016.
got it. Okay. Which, by the way, is pretty darn close. 1/60th, not 1/6. All right. So far, is there anything up here that you're like, this is crazy? Right on. Okay. So the next thing we want to talk through is how do we figure out what our margin of error should be? Are you guys good with this idea that being right about 95% of the time is a pretty good correct rate? And as I said, right, like, so if 95% of our intervals contain that actual value of p, that feels pretty decent, yeah? Okay. Nico, how far are you from me, give or take?
15 feet.
15 feet, right? That's how much, we'll go with 15 feet. I'm not very good at that. I'm good with 15 feet, though. I think that's a decent estimate. Okay. I'm going to change that question ever so slightly for you guys, okay? How far am I from Nico then?
15 feet.
It is a very subtle difference, right? The distance from Nico to me versus the distance from me to Nico, technically slightly different from each other. The value is the same, but they're not quite the same question. Is this okay? So, and the reason I say that is like, if I asked you guys now from here, we'll say this is maybe 10 feet. And instead of 10 feet, why don't we do it this way? How many steps do I have to walk to give Nico a high five? Give or take.
6.
Okay, hold on. Nico, stand up. I just walked 4 steps this way, right? How many steps does Nico have to walk to me to give me a high five?
6.
Well, assuming the desk is not in the way, right?
Oh, okay. Maybe.
It would also be 3 or 4, right? Right? His legs are longer, but I take big steps. I'm a fast walker. Right? Okay. So you guys. Oh, did you want to come with me?
Oh, okay, I mean,
Oh, too slow.
It was 3 steps. Wow.
I should have done up high, down low, too slow. Like the true dad joke. Okay, you guys. 95%. Does 95 sound familiar to you guys?
Yes.
95 feels like a percentage we sure do use a lot, right? Does anybody remember it?
Isn't it like 68, 95, 99.7?
68, 95, 99.7. 68, 95. So what was that 95? 99.
Second. Standard.
It's 2 standard deviations. Is everybody good? So if I went to like, I don't know, if I drew a line here and here, you guys with me? And that this distance was 2 standard deviations, which you guys happens to be equivalent to 0.032. Yeah? Is this okay? And this is also 2 standard deviations. Is this okay? Everybody good? Man. So, if I were to say 95% of the p-hats are within 2 standard deviations of p, as long as those p-hats were normal. That's a big idea, right? We said that normality makes things easier. Would you guys be comfortable with this statement? Are we all comfortable with this idea? That 68-95 rule. And if it's normal, we're talking about p-hats and p. That's what we're, observation. You know, like that we call that, by the way, the empirical rule. This is 95% of the observations or within 2 standard deviations of the mean. Well, the observations in this case are the possible p-hats, and the mean is p. Now, this is a really subtle thing, okay? So they can't be so distracting right now, okay? The way that is written, and this is like going to be an English language dissection of this. The way that this is written is like, if we know p, we can figure out where most of the p-hats are. Do you guys see what I'm saying here? And when we look at this, we're going to say, that we would attach that margin of error to the actual p. Do you guys see what I'm saying here? But in the statistical world, we don't know p. We're trying to use p hat to estimate p. Do you guys see what I'm saying here? It's a subtle difference. So I'm going to rewrite this. "95% of the p-hats I already don't like this. Okay, that says it the way I really wanted it, I think. Do you see how that's a little bit different? And when I said how far is Nico from me versus how far am I from Nico, it's a slightly different environment there. Okay, now, I'm going to do one more thing here. I'm going to pause. Okay, so we have the 2 standard deviations and the 95%. Okay, that 95% is something called a level of confidence. Okay, and it tells us the percent of p hats whose interval will contain P. The 2 is something called a critical value. And it's 100% because of that level of confidence. So if I wanted to be, say, 99% confident, what if I want to be right more than 95% of the time? Well, then I'm going to need more standard deviations to get those center p hats. Okay? And if I want to be right, remember how we kind of talked that margin of error is a balancing act of, I don't want my interval to be too wide, but I also want to be right. Right meaning capturing my interval actually has the right answer in it. Okay? That balancing act, sometimes we might be more willing to be wrong to result in a smaller interval. Okay? So your margin of error is equal to a critical value times the standard deviation. And for every single interval that we are going to do, the way you're going to find that margin of error is you're going to do a critical value times the standard deviation. Everybody good? All right. You guys will have your first quiz on Monday. I'm going to pass out the review for that quiz. You can't do all of it yet, but you can do some of it. The other thing I want to do. No, I think the other thing we're going to do is. The packet I gave you guys yesterday